Hello guys, welcome you all to the 15th session of Pandas data frame. So before we proceed, we will spend next couple of sessions exploring two methods which will help us with our data frame transformation. The first method will come in handy very soon, but is also almost universally useful when working with pandas and data in general. That is called the rename method. I have already written this rename method. So using this rename method, we will be able to change or rename our labels. Our data frame has two label dimensions. We already know this, the index level and the column level. And using the rename method, we could change either or both of them. That is, we can change either the my index level, or I can change my column level, or I can change both of them. So as always, we will first explore this method in isolation before we use it at a scale later in this section. So for that, what I have done, I have created one toy data set here, toy data frame. So I have pinged these things in the chat window. And this is also before you proceed. If some of you are watching the recorded session, so first you should type this and then you can proceed here. So let's import these two libraries and let's select, then import, fine, and then select this and then run this and then cdf. Fine. So this is my data frame. Can you see? Fine. Now we will be working on this data frame. This is a toy data frame. So let's see if I want to rename. Can you see in this data frame has 4 rows, 0, 1, 2, 3. These are my rows and these are the rows name 0, 1, 2, 3. And these are my 3 columns, age, weight, and height. Now, let's say if I want to rename my row here. First, I am going to rename my name, my rows, then we will proceed. Let's say if I want to rename this thing, this 0 with something else. That is, if we want to rename our index level, we could say, what we could say, if we want to rename our index level, we could say df dot rename, 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 and thereafter I will put inside this bracket, I will put index is equal to, thereafter, let's say I want to, this is my index, this is my index level, 0 is my, right now the name of my index is 0, first index is 0. So if let's say I want to rename this 0 to something else, so I will pass one dictionary here. This is my dictionary and the key part of the dictionary. So why we will pass this dictionary? I'm telling you first, let me do it. So let's say I am putting this 0 here and thereafter put this colon and let's say I want to name this as Anup, A-N-U-P, my name. Like this. So if I will do this, what I will get? If I do this and if I will rename it, this value 0 get replaced with Anup. So why we are passing this dictionary? So this dictionary is acting as a map of values, specifically mapping the current level, right? So this is represented by key here to the level that we want to rename it. In this case, the string Anu. So we are saying replace 0 with Anu. Now let's run this. Can you see after running? Can you see the difference? Here 0 get replaced with Anu. Now we could do the similar things. So we see that we have changed this level 0 from the first row, from the integer 0 to the string that is my, that we have specified here as Anu. So we could do something very similar with the next row. So if I want to do something very similar with the next row, what I will do, let me copy this. I'm copying this and paste it here. And now I will pass something else here. So let's do one thing. In the same way, I want to change this one also to something else. So what I can do, I will add another key value pair to this dictionary. This dictionary is already there. So I will add another key value pair. And inside this key, I will specify my current level. That is, let's say 1. If I want to replace this one with something else, and then this is acting as my key, and then whatever value, with whatever value I want to replace this, I will pass that value. Let's say this time I am passing value Varun. Fine. And again, if you run this, you will get this new data frame, and inside this you will get this Anu and Varun here. So I think you guys get the idea here. So we have been renaming the index axis. Right now, what I was doing, I was renaming the index axis. Now, in order to rename our column levels, right now I was renaming the row level. In order to rename our column levels, we simply pass a dictionary to the columns, column parameter. Here I was specifying my index parameter. That's why it is taking index. If instead of this index, I will take the parameter as my column parameter, then it will, instead of making changes in the index part, it will make changes in the column part. So let's do it. Let me take something like this thing. This part will be same. So let's paste it here. And now instead of the rows, let me take this columns as the parameter. And similarly, we will pass this dictionary in the column. Now, in the column, let's say this is my weight. And I want to replace this weight with something else. So in the key part, I have to specify this thing, this weight. Let us specify WIGST weight, and then put this. And inside the value part, you have to replace with that value which you want to replace it. Let's say I want to replace it with capital W, WEIGHT, and inside the bracket, I want to replace kg. Let's say I want to replace it with this thing. I want to replace this weight with this thing, capital weight, space kg. So if I run this, what will get? Let's run it and see what I'm getting. So what's the issue here? Columns is equal to, okay, fine. Okay, I have to, this thing was missing. Fine. So can you see this weight, small weight get replaced with capital weight, and this kg comes here. Now we can do both access at once. And one more thing that you want to understand, you should know here that we are doing the in place parameter. We are not doing the in place parameter is equal to true. That's why it is not making a permanent changes. It is just giving me a copy of the data frame. If I will make the in place parameter true, then it will make the permanent changes. And I do not want right now. That's why I'm not doing this. Fine. So this you understand how to rename my index level and how to rename my column level. Now we can do both access at once. That is, if you want to do both the row and the column access at once, you can do it. So both the index levels and the column levels all in one go. How you will do? Let's copy this and paste it here. So see, here we are making this thing, weight thing. And let's say if I want to make changes in the index also. So let's put index is equal to parameter. So let's put one dictionary. Inside this dictionary, let's see this thing. And then let's put Anup here. Is this thing? If I will do this, you will see here what I'm doing. I'm using both parameter, column parameter and the row parameter, which is my index and the columns both. So if I will do this, so this row and column both will get changed. See, can you see? Anup is coming here and this weight kg is coming here in the row. Now, I have already told you that renaming all these things, what we are renaming all these things is like uh, it's not sticking around because we did not put it in the in place parameter to be true. In each case, the copy of the data frame was returned. So we still have the original data frame with unchanged levels. So if you access this data frame, you will get the unchanged data frame. You will get the original data frame. Because I'm not putting the in place parameter true. That's why I'm getting the original. There is no changes in my original data frame. So rename supports the in place parameter which defaults to false. That means here my in place parameter is by default my in place parameter is if you take the default value, my in place parameter is by default false. Fine. See? So by default, my in place parameter is false. If I make this parameter true, then that let's say if we wanted to modify the underlying data frame, we just set this parameter, in place parameter to be true. So this is one way to use the rename method with dictionaries, specifying a mapping of the levels to either columns or index parameter or both at once. This is my one approach. Now, an alternative approach is to simply pass a dictionary. There is an alternative approach also. So what is the alternative approach? Let me put here like this. Alternative approach. What is the alternative approach? So is the alternative approach is that simply you need to pass a dictionary that maps the old level with the new ones to call a parameter called mapper. So let me write it first, then you will understand. I'm writing this df dot rename, and thereafter there is one thing called mapper, mapper. You have to use this parameter, and thereafter inside this dictionary, let's say this time I want to replace this height. So mapper, if I write HEIGST height, and then let's put height here. Let's say capital HEIGST height, or let's write here meter, in meter. Fine. So this is, let's do one thing, then I will make you understand how this is all working. So what I'm doing, I'm simply passing a dictionary that maps the old level, that is mapping my old level. This is my old level, which this data frame DF is having, with the new ones. And this is my new level. Height, fine. And this is my mapper. Inside this mapper, I'm passing this old level height, and this new level, I want this height to get replaced with new level. If you run this, let's see what happens. Nothing is happening. We don't actually get an error, but notice nothing happens either. There is no renaming going on here. The reason is that our method here calls here, the method that we are calling here, this mapper, is a bit ambiguous, because whenever we are using a mapper, whenever we are using this mapper, we have to specifically told, we have to specify about the which axis we want the web mapper to apply to. Here I am not mentioning anything. So in my previous examples, which we specified in, if I look in the previous example, I have specified columns, and I have specified this rows or index columns. I have specified columns, and I have specified index. So there was no confusion, no ambiguity was there. But with the mapper, there is, by default, the axis is 0. In this mapper, the axis, by default, the axis is 0. This is a default thing. If I run it, let's see what happens. Nothing is happening. The index axis will be renamed. So because by default the axis is 0, so this mapper is by default applying on the index axis. This thing, it is applying on this axis. And there is no index level called height. And it is not getting any index level which is having this height. Since it is not getting any index level which is having height, so this method replaces nothing. So no replacement is taking place. So how do we specify that we want this method to act on our column levels? Well, easy enough. We have to simply change the axis parameter from 0 to 1. So if I will change this axis parameter, because it is a by default, so we need to change this default value to 1. Then and only it is going to take this column level. So if I will simply change this axis parameter to 1, and now if I will run this, let's see. Now the changes, now it is, the changes is happening here. This height get changed to capital height, and can you see this? Now it's renamed. So the catch here is that when we are using mapper, we would not be able to rename both the columns and the index axis at once. This is a catch here. Because by using this mapper, we can only change, or we can only rename either row or column. because I have to specify the axis. Then and only it will work. So the axis could either be 0 or 1, but not both at the same time. So that's something which we need to be very aware of. So if we are trying to rename both axes, like both dimensions at the same time, we would be forced to use a syntax like this. We would be forced to use this syntax like this. So here, if I want to, let's say if I want to rename both axes, so I, instead of this one, I need to put something axis is equal to either row or either column. So instead of this axis is equal to 1, if I will simply put here columns, let's say if I will put columns here, columns, so it will work just fine. So what I'm trying to say you, we have to force, we would be forced to use this syntax like this that explicitly assigns to the columns or index parameters. So if I want to, let's say, use this mapper on the column, so I have to specify here column. If I want to use this mapper on the row, so we have to specify row here. So this will also work fine. So if you will run this, still everything will be fine. It will work fine. Now, but it is better because I prefer the integer-based notation because it ties nicely with the other concepts in Pandas. So it would be better if you use integer notation instead of this columns or rows. You can or index. You can use axis is equal to 0 or axis is equal to 1, because if I use df dot axis ax es a x es, and simply if I will write 1 here, so it will give me all the column things: age, weight, height, age, weight, and height. I am getting here age, weight, and height. This thing age, weight, and height. If I put here df dot axis 0, df dot axis 0, I will get all my rows. It is starting from 0 and ending at 4. So I prefer this thing because it ties very nicely with other concepts, and it's also less typing, it's shorter. So that's the rename method. So in the next session, we are going to learn about the drop NA method. How we can use drop NA in Dataframe. We have already used the drop NA in series, but we will learn how to use the drop NA in the context of Dataframe. That's all for the day. So let me commit this code to GitHub. And this is all for the day. Let's commit the code. And let me write rename method completed. Committed. Oh, cancel. First save this. I have not yet saved this. So first save this and then commit it. Yes. Sync changes. Okay. Fine. That's all for the way. In the next session, we are going to understand data frame drop in. Thanks, Kai. Keep learning, keep smiling, keep coming, keep commenting. Fine. Take care. Bye-bye.